Welcome to this explainer brought to you by Forge College. So in our previous lesson, Foundations of Collaborative Solana Projects, we basically laid out the groundwork, right? We organized our repository layout and figured out exactly who does what. But today we're taking those polite team rules and turning them into an automated, unstoppable engineering machine. Let's dive right into the blueprints for governance and code review workflows.
Okay, I want you to imagine this nightmare scenario for a second. It's 2 a.m. Your lead contributor is running entirely on fumes and cold pizza, and they decide to push a quick bug fix straight to your main branch. If you're relying on social contracts, basically pinky promises not to break the project, you are in serious trouble. On Solana, a simple mistake can be disastrous, so we need a way to completely remove the danger of human exhaustion from the equation entirely.
Here's our agenda for today. First, social rules to code. Then, governance models, followed by policy primitives, the anatomy of a workflow, a quick code owners and CI walkthrough, and finally, blueprint complete. Let's jump in. Section 1. Social rules to code.
A contributing guide telling people who owns what is nice, but at the end of the day, well, it's really just a suggestion. We need ruthless, unbribable bouncers protecting our repository's main branch. We want to take the ownership signals we mapped out previously and convert them into rock-solid, enforceable workflows. We want the platform itself to literally, physically block bad code from entering your canonical codebase.
All right, moving on to Section 2, Governance Models Explained.
Let's look at our options here. If you're a small team with a lot of trust and you need to iterate rapidly, a single owner approval model is absolutely perfect. As you grow into a medium-sized team, you want to scale up to dual approval plus continuous integration, which gives you a great balance of safety and speed. And for those massive projects where a breaking change could cause utter chaos, you move to full RFC and consensus, meaning public proposals and multiple teams signing off before anything moves.
Which brings us to Section 3, the 5 policy primitives.
These 5 primitives are essentially the gears of our machine. Owners identifies exactly who validates changes. Review requirements dictates how many approvals are actually needed. Automated checks are our testing gatekeepers. The merge strategy defines exactly how code is combined. Think of it like squashing a bunch of messy drafts into one clean final copy. And finally, release tagging. This is the version number you give to outsiders to prove your update won't break their apps.
Let's zoom in on automated checks for a second, which are often run via continuous integration or CI. These are your ultimate mechanical filters. They don't care about excuses, and they certainly don't care that it's 2 a.m. If your automated Rust tests fail or the system can't generate your program's instruction manual, there is no way you're getting in. Merges are completely blocked until the code is proven mathematically and functionally safe.
Section 4. Anatomy of a workflow. So let's trace the exact life cycle of a safe pull request. A contributor opens it. Instantly, the system reads your configuration and automatically pings the right experts, so no more guessing who to tag. Simultaneously, your CI pipeline spins up and runs all the automated tests. Once the machine gives the green light, human reviewers step in to check the logic. Only after both the machine and the humans approve does the code finally get merged and tagged. But hey, we also have to be practical here. You can, and really should, adjust this strictness based on the actual risk. For minor documentation typos, like you see on the left, you can allow an expedited path with just one approval. But for irrevocable on-chain program logic on the right, you demand maximum security. We're talking strict reviews, multiple approvals, and rigorous testing. This way, you keep the main branch stable, but you preserve the ability to move fast on non-critical updates.
Section 5. Walkthrough of code owners and CI.
Check out this tiny but immensely powerful snippet. This single line in a code owners file automatically routes any changes in the token program directory directly to the token maintainers team. It's a real game changer because it completely removes human error. If a junior developer modifies the token program, they don't even need to know who the lead engineer is. The platform automatically tracks them down and assigns them for review. How cool is that? Meanwhile, your CI workflow file is doing all the heavy lifting in the background. It automatically spins up a test environment, installs the Solana CLI, and executes your formatting checks and code tests. You literally just set a rule that says, this test must pass before merging, and suddenly your human reviewers can stop arguing over code formatting and focus entirely on the actual design of the program. And finally, Section 6, Blueprint Complete, Next Steps. As you build out your own projects, I want you to remember these 3 golden rules. First, align your strictness to the actual risk.
Second, automate the boring, repetitive testing so your humans can do the high-level thinking. And third, always document your fast-track rules so your contributors know exactly how to push low-risk changes without getting bogged down in unnecessary red tape.
We have built an incredible machine for a single repository today. But, this leaves us with a pretty provocative question. How do we apply these centralized policies across dozens of interconnected repositories and massive teams without absolutely losing our minds? Well, we'll tackle exactly that in our next explainer, Scaling Version Control for Large Projects. Until then, be sure to visit forge.college to master even more Web3 engineering topics. Thanks so much for joining me.